So very warm welcome to the day 5 second video which is related to the linked list today. So before that, on this day we have just discussed about best time to buy and sell stock in our first problem. So today in the second half, or in this half, we're going to talk about the linked list. So what is linked list according to you? So talking about linked list, so linked list is a linear data structure again. So continuing our tradition to solve some problems on Leetcode and other competitive platforms, we have chosen Leetcode for today's video, and we're going to solve 3 questions on the Leetcode which is related to the linked list. But before that, we're going to understand some sort of basic aspects of what linked list is actually and how we can implement it in Python. So let's see, like linked list is a linear data structures where elements are not stored at the contiguous memory location. Now what this line actually means, so we all know that when we talk about the data structures like list, suppose I take an example of a list, like this is a list, normal list. So here what is happening, if I take example of this, suppose this is a memory. If this is my memory and if I consider this as a one contiguous block of memory, so like this, there can be 2 arrays which is right now placed in my memory, but here this particular area and this particular area of my memory get lost, or it is actually termed under the wastage. So how to fix that? Like when we talk about the contiguous data structures which was contiguous in the memory, or when we break it down into the memory blocks, so if I take example as this is 110 and this is 104, 108, 112 and 116, so they are stored in the contiguous memory blocks. But when we talk about some sort of aspects of it, like if I take example of 2 to 3 arrays, suppose I have 2 arrays, and if I represent these arrays in form of these particular blocks in the memory, so you will notice one thing, that this area gets lost, or they are actually facing the memory wastage. We are actually facing the problem of memory wastage. But when we talk about in a small scenario, then it's okay, there is no problem over it. But when we talk about the large application, if I take example of an application like WhatsApp, if I take example of application like Facebook, if I take application like Office 365, so when we talk about this particular application, so you will notice that they contain lots and lots of data which is related to users, which is related to some sort of features and etc. So when our database got increment, or when our database got increased, so the major problem which we're going to face is of the memory and time. So data structures was ultimately discovered, or the focus of data structure is to do the task in such a way so that we can do it in a minimal time complexity and also in a minimal space complexity. We want to save both time and space. So that's particular thing, and because of that, these all data structures, we studied all data structures. If any wise person asks you the question like which data structures is you like the most, or which data structure is the best data structure, so the answer to this question is very much ambiguous. Like you can answer the question like all data structures have their significant purposes of solving, and each data structure is unique in itself. So linked list, now to save that particular memory block, what linked list actually can do, instead of storing the data in a contiguous fashion, what linked list can do, linked list can store the data by using the links. Like suppose I store 2 data blocks over here and then over here. So like this, linked list is very much helpful to us. We will see it implementation in Python, even how we can just create a node and what are the complex or the complexities of this particular problem. So it is very easy concept. So this is the basic, and today we're going to discuss about some sort of 3 questions on linked list on Leetcode. But before that, we're going to figure out how the linked list got actually created. So when we talk about linked list, so the simple diagram of linked list look like this, where there is a head, and that head points to the first node. This is considered as a node. Node contains 2 things. Node contains the data and the address of the next node. And why it contains the address of the next node? Because I need to point this node to the next. So because to create a particular link between them, we actually store the address over here, right? And talking about the last node address point towards the null. So this is the example of a single linked list, or a singly linked list, you can say. It's how it actually looks like. Like let's take an example. Let I consider a head node over here, and I have 1, 2, 3, 4. So this head will contain the next of 1. The next of one means if I make you understand, this is my terminology of understanding. So how I can just easily understand it, next one is the address of one actually. Okay. Now this one contains the next of 2 or the address of 2. Okay. And because of that this link is also created. This 2 contains the next of 3. So because of that this link also happened. It contains the next of 4. Right. And this link also and this contains the null. So it contains the next of null. Very much simple to understand this thing, right? So like this our connections got built up and we will just continue with our linked list, right? Elements in a linked list are linked using pointers. Very much truly said, like we are using pointer because pointer is a memory concept, and memory is also, memory address is actually used here to link the nodes, right? So that's the stuff. Okay guys, pretty much clear. We have understood the basics, like how actually linked list looks like. So talking about the Python language, now I will talk about specific about the Python. As I have just, this video is a part of a 50 days challenge. We are just focusing on creating one of the finite series on interview preparations. We will just cover the basics of Python even, and also some sort of data structures concept and the questions on the Leetcode even. So this is a very significant dynamic series which you can watch over here, and you can please like, share and subscribe so that we can create an awesome contents over here. Okay, so now let's implement this thing in the Python. So without wasting any time, let's implement. So first of all, I will require here 2 classes. Okay, first I will require one node class, because as we know node contains 2 things. Node contains the data and the next, right? This is the basic the things which a particular node contains. So how we will use the oops concept to just implement it? We will use one class. We will create one node class, very much dynamic and very much significant. Simply we have just created a new class over here. Now how we will just solve this problem? How we will solve this problem? So let's see. Now we will write one function here, and it will contain from the user. And similarly what we will write here, what are the 2 things? Like first thing is the data. So self.data will be equal to your data, and the next thing like self.next is initially my, right? So this is the basic node which I just created right now in front of you. So this is the node structure. So you can just make a box over here and you can write class node. This is the first class which you require for the linked list implementation. Talking about the next class will be your linked list. Now we will use that particular class over here, okay, to understand it. So dynamically we are speaking. Now we will again create one init function over here. It will contain some self, and here what we will do? Self.head is equal to none initially, because we are starting from our head pointer. We will start from the head and just we will go like this and then to the null. This is the basic layout of a linked list. You also guys can understand this thing. So this is the basic layout guys, which I think you can also understand. Okay, moving forward, what we will need now this is the basic structure. So first we will require one function so that I can make my node entry. So let me consider one function to, if I want to add the elements in the beginning of a linked list, then how I can add the elements in the beginning of the linked list. Let's take an example. Right now I have only this linked list. By this code I have only this linked list which look like this, like there is one head and it is pointing towards the null. Simple. Now I have to add the elements over here. Then what I will do, I will change this. How I will do? Like simple, if it is doing like this, I will simply come over here. This will contain some next to the null right now. What I will do, I will change this next to the null to the next of a particular element which I will enter, right? And this particular element, or suppose I have to add 1 over here. Okay, so this the next of null or the next of that head particular null, I just have to change this to the this and next of one to the null. Simple. And by this I will be able to add one over here. So like this. So how this code will look like, how the code of the following will look like. Okay, now we want to insert at the beginning, so let's create insert add, and which value it will take? It will take to data. Now how we will do it? Right now we have only discussed how to do it. First we will have to create one new node. So how we will create? We will use this above class now, which we have just created, this class, and I will just pass the value. If I take as example as 1, so I will not add 1 over here, I will write data, because I am just creating a function. It's a functional programming concept. Now if my head, and I cannot write like this directly, I will write if self dot head is equal to none. Simple. And I can not write equal to, if my self dot head is none. If my self dot head is none, then what I have to do? I just have to change like what we have discussed. If my head is pointing towards the none right now, next of head is pointing towards the null right now, and I just want the entry of 1 over here, then what I will do? I will just change the next of head pointing towards 1 and next of 1 will point towards the none. Simple. Like this I will add this thing here. So simple, we have to just change. So self dot head will now point towards the data or that particular new node, right? So I will just write new node. First step is done. Now I have to do the second step. In the else case, if this is not null, then what I have to do? Then right now, how I can just make you understand this thing. Okay, right now dot next is equal to like this is case. Actually it is saying like, suppose this is created, and if I want to enter 2 over here, then what I have to do? Then the next of 1 is right now pointing towards the null, right? So I have to change the next of 1 point towards the 2, and next of 2 should point towards the null. So like this I have to change, right? So when I will just do it, it will get switched. So this particular else case is for this case when we are not dealing with the head. If we are dealing with the head, then this particular statement will be useful, but when we are not dealing with the head, then this particular statement will be useful. So like this we will have to do. So my new node dot next will now point towards dot head, and self dot head will become new node. So by this code we are doing this stuff. Okay, so like this my simple implementation is done. Now if I want to print the linked list, then how we can do it? Like create one function also to print the linked list. So I will just take it as println, and it will take one self over here, and in here what we will do? We will run one while loop. So first of all we will store the current node. Self dot head is my current node, and from here what I will do? I will run one while loop, that while till my current node is not null. Then what I have to do? I have to print the current node. And by printing this, every time what I have to do? I have to go to the next value, right? Dot next. Correct? like this, simple. So we have just implemented this thing. Now it's time to get a code or a coding point of view here. So you can take example of this code like this. Suppose this is the thing and we want to print this linked list, then how it will go. So first, current node is the self, my head is here. My head is here. So 1 will be printed. Then my current node will be updated to 2. So 2 will be printed. Then again it will update it to 3. Then I get one prompt. Then now my current node is none. Then what will happen? I get my prompt. So it will stop the loop and it will print like 1, 2 and 3. Simple. Simple stuff. Very much easy to understand. I hope I just created easy for you to understand this concept. So now we will just code it over here and let's see how it looks. So without wasting any time, let's go to our VS Code. So now we are at our, okay, I'm opening the VS Code for you all guys, and you all know from now onwards you will get the codes. So it's a matter of joy, because when we talk about the things like these, it really matters. It really matters a lot. Let me go to the coding stuff where I just kept that folder. Yeah, it's a placement preparation folder. I am just opening it and I will create one new folder in front of you. Now your screen will be visible to you. Okay. Okay, now it's visible. Okay, so now what we will do, we'll create one new folder which will be the linked list. Okay, so this will be my linked list folder, and we'll create one new basic implementation. So it's basic, so I will just write basic.py. Okay, got the things works. Okay, so first what I will do, as we have just written our approach, first we will create one node class. So in the node class, what we will do, we will create one basic function and it will contain some data, and here what we will write, self.data and self.next will be my none. Simple guys, very much simple. Okay, so this is my basic node which I just created. Now what I will just create, I will create linked list class, and in this I will again define one init, and it will take one self, and what it will do, it will just self.head will be my none. So this is the basic which we have just created. This is the basic linked list which head is pointing towards the null, right? Now we will create one function like def insert at beginning. So it will take two values, self and data. I have to insert at the beginning. So first what we will have to do, so again what we will have to do, we will create one new node. So talking about the new node, what we will do, we will simply take node and we will pass on the data here. So I got my new node here. Now what I will do, I will check for the condition that if my self of head is none, then you have to go inside here, and what you have to do, you have to just change your self.head to new node. Simple. It's a case where your head is pointing towards the null, right? It's a case where your head is pointing towards the none side, right? This is the case. And if it is not, then it's a general case. Then what I have to do, then new node dot next will be your self.head, and then your self.head will be a new node, right? So like this we have just created one function which is insert at beginning. Now we have to print. So when you talk about the print, I will create one print linked list, and what it will take, nothing, it will just print the values. So like how it will do, so which will be my current node, self.head is my current node, and then while my current node is, I can also write my current node is not equal to none. I will write like this, Okay, and you can also write current node over here, it matters. Now what I will do, we will check if my, okay, we will have to just print the current node, and then what I have to do, my current node will be my current node dot next, like this. Okay, like this, you can understand. So you have created now the basic. Now what we will do, now we will just try to print it. Let's see. Now we will just easily do the computations. So we will create one main function over here, and then what we will do, simple. Firstly, we will just implement the linked list, right? So how we will do it? Let me create an object of a linked list. Like this, I will create one L1 object. Let me take an example here, like L1 is the object. Now what I have to do, I have created an object, then I will just pass the new value, like insert at the beginning. Let me pass 1 here, and let me pass 2 and 3 also. Okay, 2 and 3 also, and then L1 dot print ll, I will just call this function, and let's see. So when I just run this Python file, okay, so it is giving me node object at this, node object at this, node object at this. So I think I just done one mistake in the printing part. Yes, I will have to print the data over here, so I will just call the data. Okay, so if I will not do like this, now you can see 3, 2 and 1, it's coming, right? So the mistake which we made, like we are just printing the node, we have to print the data of the node, right? So we will just write node dot data. That's the problem only. Okay, now it's solved. So like this we will do, like this is the basic simple implementation. Okay, so it works fine. Now let's come back to our intuition or the solving purposes. So like this, you're just seeing that my linked list looks like this: 3, 2, 1, none, and here is the head. So like this, my linked list is actually looking, which I have just created because we are just inserting the new elements over here, right? So this is the basic implementation. It's a very basic, it's a very quick and basic implementation of linked list which we have done in this Python. Now we will discuss about one problem. We are coming to the problem now, and the problem which we are going to discuss first is considered as the reversing the linked list. So this problem is on Leetcode. This is the Leetcode problem, and we will understand it, how it's actually work. So what you have given, so I'm just reading the problem from here. So you have just given one linked list. For example, this is the linked list. You have given 1, 2, 3, 4. Let's take example of this linked list. You have to just reverse it to the 5, 4, 3, 2, 1. Like this it should look, or 5, 4, 3, 2, 1. You have to just change this particular thing to this. So how you will do it? So what you have to do, basically here, what you have to do, let me take an example of a small linked list like 1, 2 and 3, and this is pointing towards the null, and this is actually my head. Okay, so now what I have to do, if I want to reverse this, then what approach I can use, for the reversal of this particular thing. So to reverse this, I will take the 2 pointers now. I will take the 2 pointers to reverse it. The code is very simple, just understand how it looks. I will take 2 pointers, one will be my previous and one will be my current. And you can just write current also as CURR. Why I am saying this? Because you should understand the question over here, right? Now where my previous will be pointing, where my previous and where my current. So my current will be over here and my previous will be over here. My previous is on none and my current right now is on head. Correct? Like this. I hope it's clear. Pretty much clear, guys. This is the first case. Now the things actually got changed. Now what I have to do? Firstly, what I have to do, I will run I will go on till I reach to the this particular point. You can also consider it as a none. So till I reach to the none, I will go on moving here, correct? So from here I get my condition, which is till how much time I will just go. Okay, so till this particular time I will go. Now what I have to do? Now to reverse it, to reverse this particular thing, what I will have to do? Firstly, my head is pointing towards the 1. My head next is pointing to the 1, right? So now this particular thing, like head is pointing towards the next, I will have to change this particular thing to head is pointing towards the null, and my head of 1, my 1 next, which is pointing towards the 2 right now, I have to change this to, I will have to change this to pointing towards the head. What is happening? Just understand it critically. I have to change this, head is pointing towards here. I have to change this pointing to other, right, to the next. Got the thing? To the next. And this one is right now pointing towards the 2. I have to change this pointer pointing towards the head. Like this I have to change, right? Like this I have to change. So that's why I just use this thing, and when this particular iteration will be completed, it will move again further. Now this previous will come to here, this current will come to here, and then similarly we will do the things. Just I have to change the addresses. Remember these words. Just you have to change the addresses and you will just arrive at a particular point. Just you have to change the address. Okay, so like this you will have to change the addresses. So let's see again, let's try to understand this again. So how you will do it? Let's take one variable name as next. In next I will store current dot next. Okay, in next I am storing this thing like the address of head, or if my current is over here, then I am storing the address to which this particular node is pointing in by this line. Now what I am doing? Now after storing, I am changing this address to which it is pointing to previous. So this will now point, instead of pointing over here, this will point like this. That I am trying to tell you. Okay, and after this particular thing, I will now again shift my pointers. So when I will shift my pointers, then my previous node will now become the current, and my current will go to the next node. So like this we are just going over here. Again, try to understand. I make you understand this thing again, because this is the very much basic concept to be understood. Like this it's look. Okay, I have my previous and current pointer here. So now let's understand. Let's understand this question again. Okay, so my previous is not here, my previous is here, and my current is over here. So first what I have to do, I will have to store this particular address. Like this node also contain one address na, and this address is nothing but the address of 1. This also contains the address to 2, right? So first what I have to do, I have to store this address somewhere. So first I will store the address. So how I will store? I will create one variable which is nxt. I am giving it nxt, and here I am storing current dot next. And after that, after storing this particular address, what I am doing right now, you understood this thing? I have stored this address. This address is now with me. Now I will do what I will do. Now I will change this address. Why I will change this address? Because I have this address stored now, so there is no problem of data loss. I just have to change now this. So I will change my current dot next point towards the previous. Previous is my none over here. So what I will do? Just write previous. So now instead of going over here, this will go to here. So my linked list got reversed. After reversal, I will have to just move previous and current pointers again. So how I will do it? How I will do it, guys? Very much simple. Now my previous will become the current and my current will go to the next, because this thing will help me to go further. So that I have just stored in this, and then after the current will use it to go to the further, and this is the actual code of importance. That's the thing. Until how much time it will run? It will run till you reach to the none. Simple. Till you reach to this particular point, it will run. Very much simple. Guys, got my point? Till your current reach to the null, it will run. So like this, you can easily reverse the linked list. Got the thing? Like, share and subscribe, guys, if you understood the concept of this thing. Okay. So let me do the code implementation part of it. Now we will go to the Leetcode. Let's trash some keys, right? So we are at our linked list reversal problem. So what I have to do now, guys, again look very much carefully. I have created two pointer. One is previous and one is your current pointer. Now my previous is pointing to the none and current is pointing right now to the head. Right? Now what I have to do? Simple. I have to run the loop till I reach to the none. Very much simple. And here I have create one temporary variable and it will store the current dot next, and then my current dot next will be updated with the value of the previous, and then my previous will be changed to current, and then my current the current will be given to the value current dot next, so that it can move to the next node. Right guys, and what we will have to return? We will return the previous, because my current right now is on the null. So till previous, when you want to move forward, we're going to print the current previous. Okay, let's see. Okay, so it's giving me the wrong answer. Great. So I expected this, and output is giving me like this. Okay, so where is the problem? Where is the problem in this question? We have just reversed it. So simple. Let me see the problem where it lies. Okay. So it will be next. Okay. Really? It's a very minor mistake which you have done. No problem. Yeah, we just solved this problem. Bonsai, guys. We have solved one problem, which is the reverse of the linked list. Now we will talk about our next problem, guys. Okay, now we will talk about the next problem, and our next problem is nothing but we have to find the middle point of the linked list, right? We have to find the middle of the linked list. So how this problem actually looks like, here is the problem. So you are given one linked list. I am writing this problem. Okay, so I have to find the middle of the linked list. Let me take an example of a linked list. 1, 2, 3, 4 and 5, as it is mentioned in the question, right? Let me take an example of a linked list. So what it is telling me, if I have given a head and this head contains 1, 2, 3, 4 and 5, this is given to me, and I have to return the output as 3, 4 and 5. Why? Because 3 is my middle, and from 3 to next to the end I have to print. That's the thing, right? Because my middle is node of this node is 3, and when you talk about the middle of this node, so we are considering like there are 6. We are 6, then we are just moving one forward, like 4, 5, 6 is the now our next solution, right? So this is the particular thing. how we have to just solve. Now I will have to print 4, 5 and 6. Like this, 3, 4 and 5 I have to print. From the middle to the end, I will have to print the values. Now let's see how we can do it again. So here also we use 2 pointers. Again we will use the 2 pointers, but they will be slightly different in the working. Let me go to the pad again. So here is my pad. So okay, now what I have to do? Again I have to go in this direction only. So now what I will do, like this is the linked list you are given, and what you have to find the middle of the linked list. Suppose this is the middle of the linked list here, so you will have to print 3, 4 and 5 till the end. Till the end you will have to print. Till end you have to go. So for that, how you will implement? So you will take the 2 things over here. Okay, you will take 2 things over here. I will take one slow pointer and I will take one fast pointer. I will consider 2 of the pointers over here, and let's see how this approach actually looks like. So let me take a linked list. This is the linked list 3, 4, 5, and this particular thing is right now pointing. This is my head, and head is over here. So here my slow is also here and my fast is also here. Now how we will find? So we will go on over here till we reach to the none. Okay, this thing we have pretty much clear. Like this only we will do the traversal, so that we can go till end. And now talking about the first iteration, this slow will move to the here. Very much clear. And this fast will move to here. Okay, so like this is the first iteration. Correct? This is the first iteration by which we are moving. Then what will happen? Very much simple. Then what will happen? Again the same thing will be doing. Again the same thing we will be doing. When my this particular thing or the 1 will move to 2, this fast will move to the 4, and we are printing 1, 2 we have just got, right? Now let's go again. Okay, like this. Now what is happening? Now when my slow will move to the 3, then this fast will go to the next part other than that. So like this we will reach till the middle easily. So by using this approach we will meet over here, and then you just have to print. Like this you have written to the middle, we got to the middle, and then you have to print. So how we will write this implementation? Because you are just seeing that slow is moving one step and fast is moving next to next. So slow is moving to slow dot next, and my fast is moving to the fast dot next. So like this it is going on. So it's going on 2 steps, and slow is going on one step. So by this I will divide, or you can say you will go to the middle. Till middle you will easily go, right? So now how to do the implementation part of it? Let's see. So when it comes to the implementation part, first of all you will require 2 pointers. One is slow pointer and one is fast pointer. Both will point to the head. Now you will run one while loop. So while till your fast and fast.next is not getting null, what you have to do? Simple guys, what you have to do? Just you have to go one step. And then ultimately we will gonna return slow. Correct? I think it's clear. Why I return the slow? Because this slow will be on the middle. Got the thing? This slow will be on the middle, and after that the thing which you need will be printed. Simple. So let's see how this implementation we can do. It's a very short code, but it contains a huge concept underlined, right? So let me go to the VS Code or the Leetcode problem, and let's thrash some keys and let's kill this question. I will use some slow and fast pointer again, and this slow will now point me to the head, and this fast will also point to the head. And while my fast and fast dot next not get null, what I have to do? I'll simply have to increment the slow dot next, and fast will be incremented to the fast dot next. Simple, very much simple of implementation part, and we're going to return this slow. Simple guys, very much simple, because fast will be at my null. So by using this 2-pointer approach, you can easily kill this question, guys. Again, let's see. Okay, so we are just getting the wrong answer. So where is the problem? Let's see, and let's debug this question. Here is the problem. I have to point to the next. Okay, and let's see. Yeah, it worked. Great, guys. So we have killed the second question also now, and now we will point to the next question, or the last question for the today's video, and it will be the Pallindrome linked list. Now this linked list concept will include the 3 concepts of yours. The first concept which this particular Pallindrome linked list will cover is the reverse linked list we have just seen right now, middle of the linked list which we have just seen right now, and your comparison. So it will contain 3 concepts. It will contain the 3 concepts. One is your reverse linked list, second is the middle of the linked list, and third will be your comparison. Okay, so this question will contain 3 things. So let's see how this question actually looks like and what you have to do in this question. So I will make you understand in this a very approachable way and in a very easy way, so that you can easily understand this problem. So as I've seen, this will include the 3 concepts. These are the 3 concepts. 2 concepts we have already done a check mark, and this question will help us to just revise those also and to come to a basic problem or to solve this one. Okay, so let's see how this problem actually looks like, guys. Let's see. 1, 2, 3, and let's take example that it contains 2 and 1 over here again. Okay, so talking about the palindrome, you all guys know what palindrome is. Like if I take this as a value and if I take this as a value, they both are palindrome. Why? If I go on reversing this, if I go to the reverse, then it will be 2, 1, 0, 1. Okay, so not this thing is not a palindrome. Sorry from my end. If I write like this, 1, 2, 3, 2, 1, and if I write from here also, then it will return the same thing. This thing is known as the palindrome, right? This thing is known as the palindrome. So now in the linked list, how you will check? How you will check that whether this thing is a palindrome or not? So simple approach what you can do, simply just first go to the middle of this linked list. First step is going to the middle. So for going to the middle, we will use our slow and fast pointer again. So to go to the middle, we will use our slow and fast pointer, and my slow will point to the 3. I just got my slow over here. Next thing, what I have to do, I have to reverse this particular linked list after this. Like this, it is written 2 and 1. So I have to reverse this. It's very much simple. Next concept will be involving is the reversing of the linked list. So in reverse, we use 2 particular pointers, previous and current. Thing is clear? Previous and current, 2 things we require here. So now that slow will become my simple, like this. And third, after reversing, we will compare. How we will compare? Let's take example, and it is pointing to the null now, and sorry from my end. So it will point to the null, and then this particular thing, I have to reverse this, so it will look like this. So now what I have to do, I have to just check. Let's take for checking, let's take 2 pointers more. For checking, let's take T1 pointer and let's take T2 pointer, which will check. So First we will check whether these values are equal. Yeah, they are equal. Incrementing the pointer to the next. Now checking again, they are equal. Yes, they are equal. Now incrementing again. So I got null here. If I get null over here, I will stop the comparison. I will return that they both possesses the property of a palindrome. Why? Because I am not getting any value mismatch over here. It's written 1 1 1 1 also gets matched, 2 2 also gets matched, right? So that particular thing worked. If I get this, if I got something like this 4 2 and then null and then null, then at this particular edge case it will get failed. Very much easy, guys. Got my point? How this thing actually we are seeing this particular problem. Okay, easy. Okay, so we are using three things here. One, we have used middle. Second, we have just used our property of reversing, and then we are just comparing. So how this coding it will look like? So firstly do the stuffs. You can easily see the code of yours. What here does done to find the middle. First you have to find the middle. So how you will find? You will use one fast and slow pointer. Initially they will both point to the head and head, and then you will just run till your fast and fast dot next becomes null. And while running this, what you will do, slow will be incremented as slow dot next, and your fast will be incremented as fast dot next. So like this we have just figured out this thing. Now remember one thing. After this step I am writing one note. Your slow pointer is current. Now your slow is current, so you will require a previous pointer also. Okay, this thing you have to keep in your mind. I am giving you one insight. Okay, now your slow is your current pointer. That's why I haven't changed the name of the pointers, so that you can easily map this concept. So like this, now I know that now slow, I have to consider my slow pointer as the current pointer, and I have my previous pointer, which is I have created a none pointer, right? Because slow is now acting as or my current is now pointing towards the head always. So previous I have to create one pointer, previous pointer I have to create, and then what I will do, I will just go into the loop, and then inside the loop what I will just ask, how we actually does the reversing. We will write the current pointer over here. Here my current pointer is slow. Then I will just write the basic concept, simple. So how it look like, slow dot next is equal to your previous, and your previous will become slow, and slow dot next will become your next. Simple, guys. I hope there is no problem in understanding this thing. So this is the second kill you have done. Now you have to do the comparison. Now you got the reverse linked list, and one you have just got your normal linked list. Now what we will do? Now simply we will do the comparison stuff. So how we will compare? We will use T1 pointer and T2 pointer. My T1 pointer is where? Where is my T1 pointer? My T1 pointer is by the head of the linked list, and T2 pointer is right now on my previous of the linked list. Simple. Now you have to do the comparison. Okay. So till your T2 becomes null. Okay. Till your T2 becomes null, because your T2 is on the previous. So till the T2 becomes null, what we will do? We will just check, like if T1 dot value, if in the case these values will not get equal, then I have to just return the false in that case. But if it gets equal, or if it's getting equal and we're just going on again and again, so T1 will be equal to T1 dot next, and T2 will be equal to T2 dot next. So like this we will go on, and ultimately we will return the true if this thing gets successfully executed. So like this we're gonna code this answer now. So you have just got the basic approach. We have just broken this problem into three aspects of it, and we are just going on one by one to all of that, right? So let's see the coding implementation part of it again. So now I will just head it towards the coding implementation part of this. So we are on the VS Code. No, we don't want to go to the VS Code. We're going to go to the Leetcode. Okay. So now we are on the Leetcode. So how we will do it again? Let's see. First, what I will do, I will have to find the middle. So fast and slow, both are pointing to the head, and then when my fast and fast dot next is not null, what I have to do, slow will point toward the slow dot next, and my fast will point towards the fast dot next dot next. Very much simple, guys, very much simple. But remember one thing, don't make this mistake. Okay, now you know, guys, that my slow has become the current right now by using this code, and now I am on the middle. So I will create one previous which will point towards the none, and similarly till my slow goes on, till my slow goes on, or till my current nodes go on, I have to just create one variable, and I will just store slow dot next. Consider this as your current, right? And then slow dot next will become your previous, and then your previous will become slow, because we have to just increment it, and then your slow will become next. Now again, very much good concept, you understood this thing. Now you will require more variables, which is t1 and t2 for solving. Now t1 will point to the head and t2 will point toward the previous. Now while till my t2 gets null, what I have to do, I have to check if my t1 value is not equal to t2 dot value, then what I have to do, I have to just return the false. Very much simple. Else what I have to just return, what I will do, I will simply go on, guys, simply go on, and I will just move this thing like this. I have to apart from this, you can go in the else also. If you don't want to go, then you can write directly even here. You have to just go next to next, then t1 will point to the next, and your t2 will also point to the t2 dot next, and like this you will just go on and you will get your answer. And if this thing persists and if this thing goes well, then you will just return your answer, right? So let's see how our answer looks like. Okay, so there is one problem, like list node object is not having any object like value over here. Let's see, let's take it as a val. Okay, I think that it's given the input as a val over here, so I will just write val. There is no problem in it. And let's see the implementation part. Let's enable the problem persist. Okay, so it worked. So you have solved one complicated problem, and this problem is very much good if you solve. And this is the beginner problems, which we have just solved 3 problems. One is the medium one, and second 2 problems were the easy one. So like this, we have just done the basic concept of linked list, how the basic concept of linked list actually looks like. So pretty much, guys, you will get the code below in the description. So that's I have to tell. So if you really like this video, please like, share and subscribe and share with your friends. And I'm just going to meet you in the day 6 tomorrow, and again we want to discuss some sort of great problems. So what I will suggest to just try the Leetcode 75 interviews problem before, and tomorrow I want to discuss about array and strings, and let's see how these particular concepts looks like. And talking about the linked list, there will be 2 more videos on the linked list. We will discuss about the doubly linked list also. So there will be 2 more videos which will be coming on the linked list. So today you have done the basics of the linked list, and you have just solved some great problems, and you now know that if the problems of linked list comes in your examinations or it comes in your interview, you can easily ace them. So thank you so much, guys, for giving this so much of love, so much of support, so much of positive attitude from your side, and we will be contributing in your journey till we are here. So don't worry, we are with you, guys. Thanks for watching this video. See you soon, guys, in the next video in the day 6, and keep following the 50 days challenge. Bye.